Hi everybody. I wanted to go through a few things on reflections and symmetry. So a lot of this should be reviewed, but hey, we want to make sure that things are okay. And so the key piece of information here is that when we have a reflection in the x-axis, some people call it like a vertical flip, we are negating the function. And by negating the function, the points all go from xy to x negative y. So if we look at this one, right, so if I have negative 3, 1, now I have negative 3, negative 1. Negative 2, 0 doesn't move. Negative 1 comes up. This doesn't move. This goes down, and this goes over. So there is my graph, in this case, of negative f of x. The same thing with this parabola. If we got 0, negative 3, now we got 0, 3. We gotta quickly do my 1, 3, 5 method. And there is my vertical flip, negative f of x. So what we have here is an absolute value. What we know about absolute value is an absolute value always spits out a positive answer. So if we look at this scenario, what we want to see is we can't have anything below the x-axis. So everything below the x-axis, in this case, will flip to become positive. So if going from negative 2 down, we're actually going to bring this up. And make our graph that. All right, so the rest of the graph's the same, but the only change is that piece flipped up. In this scenario here, right? We stay on the x-axis because it's okay to have an absolute value of 0, but our bottom piece flips up, and we have this as our absolute value graph. Now, if the entire graph, if f of x was entirely greater than 0, there'd be no change. But anytime that the graph drops below the x-axis situation, we have to flip that piece up. All right, reflections in the y-axis. So in this case, it's happening directly inside the function. And by happening directly inside the function, we are flipping the x, not the y. So this first graph, y equals 1/5 to the x, right? On my y-axis, it stays. Right? But in this situation here, I got this. Right? So this would be my f of negative x. I got that flip with the x values on the inside. And one thing I think about is, if I have f of x, if I got rad x, I got that. But if I have negative x, if we think what numbers make sense here, negative, negative 1, negative, negative 4, and that flips the graph this way. All right, so if I have a flip over the over the y-axis in this case, I go from negative 3, 0 to 3, 0, and I got this point, up here, there, and there. This is my reflection over the y-axis. Okay, so we briefly touched about this the other day. Whenever we have a scenario with reflecting over the line y equals x, right, we talked about this because we were talking about the whole f of g of x equals x idea, and this was part of inverse. And again, the thing with inverse is that an inverse has to be a reflection over the line y equals x. So what happens? When we reflect over the line y equals x, every point x comma y, that should be a y, becomes y comma x. All right, so if I look at this, I'm going to say this vertex here is 1.5, negative 2.1. So if I go over here, negative 2.1, 1.5, there's my vertex. And then I could call it a half, negative 1. I could call it 2.5, negative 1. So over here, I'd flip a half, negative 1. Negative 1/2 would be there. And I'd have negative 2.1. I'll flip a negative 1, 2.5. So I'd be there. And this would give me my shape this way. Yeah, the last piece isn't perfect. And if I drew in my line y equals x, cutting right through, we want to see that symmetrical look to it, right? So that line divides perfectly through, and we can see there's that symmetry if we flip over that. And the key thing with this is to do reflection over y equals x, we flip your x and we flip your y. All right, going over here, 0, 0 stays, 1, 1's not changing, 1, negative 1's not changing, but we got to have that different look to it. All right, our flip is going to be this and that. And our line, y equals x, is coming right through that. And what does our flip in this scenario give us? The third root of x. Which again, those are inverses. All right, symmetry. All right, so a graph is symmetric in the x-axis if the point x negative y is on the graph xy. All right, so this is just saying the fact that you have 1, 1, here we have 1, negative 1. Right, so that holds true. The graph is symmetric in the y-axis if the x values change. All right, so here we have 1, 1 again. Here we have negative 1, 1. Right up here, here we have 2, 4. There we have negative 2, 4. There's our proof. A graph is symmetric in the line x equals y if the points flip-flop. Right, so here we got 1, 0, 0, 1. Right, and our line is cutting perfectly through that. And if we called this in this scenario 2, negative 2, well, here we'd have to have negative 2, 2. The only kind of different one is if we have an origin flip-flop. So if we flip-flop over the origin, xy becomes negative x, negative y. All right, so if we look here, negative 1 becomes 1, 1. All right, if we had 2, 4, we'd have negative 2, negative 4. And those all have to hold true. All right, so again, some practice here. If I graph my origin on all 4 of these, so I got negative 3 up to down to. So here's my original. Place it on all of these. Original. And original. All right, so what happens with our flips? All right, so a negative flip, right? The negative flip on the outside is a flip over the x-axis. So what happens? All of the x values stay the same, the y values change. So if we have 0, negative 3, now we have 0, 3. If we have 1, negative 1, we got 1, 1. If we have 2, 1, we have 2, negative 1. 3, 3, 3, negative 3. 4, 5, 4, negative 5. Oh, forgot one. Negative 1, negative 5, negative 1, 5. There's our flip over the x-axis. All right, so absolute value, everything has to be greater than or equal to 0. Right, everything's got to flip up. All right, so this change spot is here when we hit that x-axis. So 1, 1, 0, negative 3 becomes 0, 3, and negative 1, negative 5 becomes negative 1, 5. And this is our absolute value. Ah, terrible, I missed. This is our absolute value graph. Everything in that scenario is positive above the x-axis. All right, here's our flip over the y-axis. Right, so keep the y, change the x. So we got negative 1, negative 5 becomes 1, negative 5. This stays the same. Flip here, flip there, and flip there. All right, last one. xy becomes yx. So if I have negative 1, negative 5, now I have negative 5, negative 1. 0, negative 3, negative 3, 0. 1, negative 1. in the scenario, by flipping, well, what's really happening? In this case, I got a slope of now a half because I have the inverse graph of the original.